This is Mercury, the closest planet to the Sun, but it's not what you think. Imagine standing on its surface, where the sun rises in the sky, then suddenly slows down and begins to move backward. Yes, on Mercury, the sun doesn't behave normally. It can stop, reverse direction, and then rise again. And when it finally reaches noon, it can stay there for weeks, constantly blasting the surface with intense heat. Beneath your feet, the ground isn't stable either. The entire planet is slowly shrinking and cracking apart. And in some regions, sunlight has never reached at all, leaving parts of Mercury in permanent darkness. For over 4.5 billion years, these areas have remained completely dark, untouched by even a single ray of sunlight. For decades, scientists believed Mercury was just a simple, dead cratered rock orbiting close to the sun. But everything changed when we finally sent spacecraft to study it, up close for the first time. Because what they discovered wasn't just surprising, it completely changed our understanding of this planet. The data shocked scientists and forced them to rethink how Mercury formed and what it's really made of. It turns out Mercury is not simple at all. It's one of the strangest and most extreme worlds we've ever seen. A place where extreme heat and freezing cold exist side by side, in ways that seem almost impossible. So let's begin with the most basic question you might ask. About a planet this close to the sun, just how hot does Mercury actually get? And why is it so extreme compared to everything else? During the day, Mercury's surface temperature can rise to around 430 degrees Celsius. Under direct sunlight, that's hot enough to melt metals like lead, zinc, and even tin right on the surface. In some areas, the heat becomes so intense that the ground itself appears to shimmer and glow faintly. But once the sun sets, Mercury transforms into something completely different. Within a short time, temperatures drop all the way down to minus 180 degrees Celsius during the long freezing night. That's a temperature difference of more than 600 degrees, the most extreme swing in our solar system. On Earth, most places only experience a difference of about 10 to 15 degrees between day and night. So what makes Mercury so extreme compared to other planets in our solar system? The first reason is simple. Mercury has almost no atmosphere to hold in heat. Instead, it has a very thin exosphere, made of scattered atoms that barely stay around the planet. This means heat from the sun escapes directly back into space. As soon as night begins, it's like removing a blanket in freezing weather, except Mercury never had any protection to begin with. But the lack of atmosphere is only part of the story. Something else makes Mercury even stranger. Because Mercury doesn't spin or move like most other planets that we are familiar with. Its motion is locked in a rare pattern, called a 3-to-2 orbital resonance with the Sun. This unusual motion means Mercury rotates incredibly slowly, compared to Earth creating very long and extreme days. it completes 3 full rotations on its axis, for every 2 complete orbits it makes around the Sun. This strange ratio creates one of the most bizarre time cycles found anywhere in our solar system. On Mercury, a single solar day from one sunrise to the next lasts about 176 Earth days. That means one full day on Mercury is actually longer than 2 entire Mercury years combined. Imagine watching the sunrise and then waiting months just to see it set again on the horizon. But things get even stranger because Mercury doesn't travel in a perfect, circular orbit around the Sun. As it moves closer to the Sun, its orbital speed increases dramatically due to stronger gravitational pull. At certain locations, this causes the Sun to appear as if it's slowing down in the sky above you. Then for a brief moment, the Sun actually stops and begins moving backward toward the horizon again. After that, it reverses direction once more, creating a rare and incredible double sunrise effect. It may look like something from science fiction, but it's completely real and driven by orbital physics. But Mercury's surface behavior is only part of the mystery, hiding within this unusual planet. Because if you could look inside, you would find something that scientists still struggle to explain. Mercury's core is far larger than expected, making up most of the planet itself. Its iron core makes up nearly 85% of the planet's radius, which is extremely unusual. For comparison, Earth's core is much smaller, relative to its size and overall structure. Some scientists describe Mercury as a giant metallic sphere, covered by only a thin rocky shell. Its crust and mantle together are surprisingly thin, compared to other rocky planets in the solar system. To explain this, scientists proposed a violent past involving a massive collision early in its history. A large object may have slammed into Mercury, stripping away much of its outer rocky layers. This impact would have blasted material into space, leaving behind a dense iron-rich core. What remained was the Mercury we see today, with a massive core and thin outer shell. Huge impact basins on its surface may be evidence of this violent and chaotic past. But this explanation was challenged when a spacecraft began studying Mercury in much greater detail. The mission collected years of data, revealing surprising chemical and geological features. Scientists discovered elements on Mercury's surface that should not have survived such extreme conditions. These volatile elements normally disappear under intense heat, yet they are still present across the planet. This creates a major mystery, because those elements should have been destroyed during any massive impact, which suggests that Mercury's origin story might be far more complex than we originally believed. But Mercury isn't just unusual in its past, it is still actively changing even today. As the planet slowly cools over time, its massive core begins to contract inward. This contraction forces the surface to compress, causing it to crack, buckle, and fold. The result is enormous, cliff-like structures stretching across vast distances on the surface. Some of these features extend for more than 1,000 km across the planet. That's comparable to some of the largest fault systems found here on Earth. It's similar to a fruit drying out, where the surface wrinkles as the inside shrinks. Except on Mercury, those wrinkles are massive cliffs and deep fractures across the landscape. Even more surprising, scientists discovered that some of these cracks are relatively young. They appear fresh and unwithered, suggesting they may have formed in the recent geological past. This means Mercury could still experience quakes as its surface continues to adjust and shift. Yes, Mercury may still be geologically active, despite its small size and extreme conditions. But perhaps the most unusual discovery on Mercury is something called hollows. These are strange, shallow depressions scattered across the surface in large numbers. And scientists have never seen anything quite like them anywhere else in the solar system. These hollows appear bright and fresh, standing out clearly against the darker surrounding terrain. They may form when certain materials on the surface slowly evaporate under intense solar radiation. As those materials disappear, the surface collapses and leaves behind these unusual formations. Some scientists believe these features may still be forming, even today on Mercury's surface. And then there is something even more surprising. Mercury has its own magnetic field. This is unusual because most small, rocky planets have already lost their magnetic fields long ago. This field is generated by a still partially liquid core, deep inside the planet. But unlike Earth, Mercury's magnetic field is shifted significantly toward one side of the planet. This causes uneven exposure to solar radiation, especially affecting the southern hemisphere more intensely. And incredibly, inside permanently shadowed craters, scientists have found evidence of frozen water ice. Ice existing on the closest planet to the Sun is one of Mercury's greatest contradictions. This is not a dead world, it is active, evolving and far more complex than we ever imagined. The more we study Mercury, the more mysteries we uncover about its true nature. And that is exactly what makes it one of the most fascinating planets in our solar system.
Thanks for watching. For more amazing space facts, subscribe to Planet Facts and don't forget to hit the bell icon to stay updated.